Welcome back, everyone. We're going to be solving LeetCode 103, binary tree, zigzag level order traversal. So essentially what this problem wants us to do is just run a breadth first search on a tree and keep track of the current levels, right? So this tree has 3 levels. Starting at level 1, we go from left to right, we traverse the tree. We go to level 2, we traverse the tree from right to left. We go to level 3, we traverse the tree from left to right. So we can see that anytime we run into an even level, then we need to traverse from right to left. So we know we're going to run breadth first search, so let's import our DQ from collections, which I've already done, and let's get that set up. Our Q is going to be equal to a DQ, and on this Q we are going to add the root value, and we are going to keep track of the current level, and then we're obviously going to need an output array. So let's run our breadth first search while the length of the queue is not equal to 0. We are going to say the current tree level we are at is going to be an empty array, and we are going to grab all the nodes in this level. So for I in range length of our queue, we are going to grab the node and the current level with q.pop left. Now we need to check to see if the current level we're at is either even or odd. So we'll say if the level modded by 2 is equal to 0, it means we need to traverse from right to left, right? This means we are at an even level. Otherwise, we are going to traverse from left to right. Okay, so let's do left to right first. So now we need to check if our node is not none. What do we want to do? Now we want to add that node's value onto our tree level. So we will say tree level dot append the node dot val, and then we will check for the left and right children of this current working node. So if node.left is not none, we will say q.append the node.left child along with the next level, so level plus 1. And then we will do the same thing for the right side. If node.right is not none, we will say q.append node.right and level plus 1. Okay, now let's handle the case where we are at an even level, right? We still need to do basically all of this, but instead of, so we can just copy this, but instead of appending the node value to the very end of our tree, level, we're going to append it to the left. So we'll say append left. And in order to do that, this is going to be constant time. In order to get that constant time operation, we need to turn this tree level into another DQ object. So we will say DQ, and this will be an empty array up here. So that'll handle this case when it's even. All right, so that is looking pretty good to me. So now, once we are done with all of the items at the current level, what are we going to do? We're going to check and make sure that this tree level has items in it. If it does, we can just append it to our resulting array. So let's do that. We will say if the length of our tree level is not equal to 0, we will simply just append it to our resulting array. And then we should just be able to return our resulting array at the end here. So let's run this. Perfect, it does pass all 3 test cases, so we'll submit. And it does pass the submission tests. So time and space complexity. Space is going to be bound to the length of the queue and the length of the resulting output. So O of the queue.length plus the res.length. The time complexity is going to be O of n, where n is the number of nodes we have to traverse, right? We have to traverse each node in our tree at least one time in order to get this final output. All right, that'll do it for LeetCode 103.